INA199A series current shunt monitors by Texas Instruments. Welcome to the training module on INA199A current shunt monitors. Today's training outline consists of what is current sensing, low side current sensing and high side current sensing, TI's current shunt monitors, INA199A current shunt monitors, and typical application circuit. A current sensor is an electronic circuit that monitors the current flow by measuring the voltage drop across a resistor placed in the current path. The current sensor outputs either a voltage or current that is proportional to the current through the measured path. A wide variety of applications benefit from the ability to measure current flow. Traditionally, current sensing was primarily for circuit protection and reporting. However, as technology advances, current sensing is becoming more and more important as a way to monitor performance. Here we list some of the applications that benefit from current sensing. Low side current sensing techniques connect the current sensor element between the load and ground. Current is measured by looking at the voltage drop across a resistor placed between the load and ground. This method is straightforward, easy, and rarely requires more than one operational amplifier to implement. But it may add undesirable resistance in the ground path and require an additional wire to the load that could otherwise be omitted. High-side current sensing techniques connect the current sensor element between the supply and the load. Current is measured by looking at the voltage drop across a resistor placed between the supply and the load. Current sensor is connected directly to the power source and can detect any downstream failure and trigger appropriate correction action. Therefore, it won't create an extra ground disturbance. However, this method requires very careful resistor matching in order to obtain an acceptable common mode rejection ratio, and must withstand very high and often dynamic common mode voltages. Current shunt monitors are a unique new amplifier family that is solely dedicated to high-side current sensing applications and contains all the necessary functions needed to perform the measurement easily and economically. There are two types of current shunt monitors, current output and voltage output. The current output current shunt monitors have low quiescent current, adjustable gains, and are available in both standard and high-speed configurations. The ability of voltage output current shunt monitors to sense at or below zero is essential in sensing current from shorted supplies during inductive kickback and can be used for negative supply current sense. The INA199A series of voltage output current shunt monitors can sense drop across shunts at common mode voltages from 0.3 volts to 26 volts, independent of the supply voltage. Three fixed gains are available: 50 volts, 100, and 200 volts. The low offset of the zero drift architecture enables current sensing with maximum drops across the shunts as low as 10 millivolts full scale. These devices operate from a single 2.7 volt up to 26 volt power supply, drawing a maximum of 100 microamps of supply current. All versions are specified from minus 40 degrees Celsius to positive 105 degrees Celsius, and are offered in both SC70 and thin QFN10 packages. This slide illustrates the basic connections for the INA199A. The input pins, IN plus and IN minus, need to be connected as closely as possible to the shunt resistor to minimize any resistance in series with the shunt resistance. Power supply bypass capacitors are required for stability. Applications with low noise or high impedance power supplies may require additional decoupling capacitors to reject power supply noise. Connect bypass capacitors close to the device pins. The zero drift offset performance of the INA199A offers several benefits. Most often, the primary advantages of the low offset characteristics enable low full-scale drops across the shunt. For example, non-zero drift current shunt monitors typically require a full-scale range of 100 millivolts. The INA199A series of current shunt monitors give equivalent accuracy at a full-scale range on the order of 10 millivolts. This accuracy reduces shunt dissipation by an order of magnitude with many additional benefits. Alternatively, there are applications that must measure current over a wide dynamic range that can take advantage of the low offset on the low end of the measurement. The INA199A series common mode rejection ratio is affected by an impedance present at the REF input. This concern is not a problem when the REF pin is connected directly to most references or power supplies. When using resistive dividers from the power supply or a reference voltage, the REF pin should be buffered by an op-amp. In systems where the INA199A output can be sensed differentially, such as by a differential input analog to digital converter, or by using two separate ADC inputs, the effects of external impedance on the REF pin can be cancelled. With a small amount of additional circuitry, the INA199A series can be used in circuits subjected to transients higher than 26 volts, such as automotive applications. Use only Zener diodes or Zener-type transient absorbers. Any other type of transient absorber has an unacceptable time delay. Start by adding a pair of resistors as shown in the figure as working impedance for the Zener. It is desirable to keep these resistors as small as possible, most often around 10 ohms. Large values can be used with an effect on gain that is discussed in the section on input filtering. Large values can be used with an effect on gain.